Take a look at a honeycomb. At first glance, it doesn't seem all that extraordinary. But hidden inside those tiny wax chambers is a design so efficient that it fascinated scientists and mathematicians for centuries. How can insects with brains smaller than a grain of rice create such a perfect pattern? Most people think the answer is instinct. The truth is much more surprising. Because bees aren't the only ones building the honeycomb. To understand why, let's start with the material itself. Unlike birds that gather twigs or beavers that collect wood, bees manufacture their own building supplies. Young worker bees consume large amounts of honey and convert that energy into wax. Tiny wax scales emerge from special glands underneath their bodies. The bees remove these scales, chew them, and mix them with saliva until the wax becomes soft and flexible. Then thousands of workers begin shaping the growing comb together. But why do they use hexagons? Why not circles, squares, or triangles? Circles may seem ideal, but they leave gaps when packed together. Those gaps waste valuable space. Squares and triangles solve the gap problem, but they require more wall material to create the same amount of storage. And that's expensive for bees. Producing wax takes a huge amount of energy. That's where the hexagon shines. Hexagons fit together perfectly without gaps while using less material than many other shapes. They allow bees to store the maximum amount of honey while using the minimum amount of wax. Humans were so impressed by this design that they spent more than 2,000 years trying to understand it. In 1999, mathematician Thomas Hales finally proved why the honeycomb pattern is one of the most efficient ways to divide space. Even Charles Darwin praised the structure for its incredible economy of labor and material. But here's where the story takes an unexpected turn. Scientists studying unfinished honeycombs discovered that bees don't actually start by building hexagons. Instead, they begin with rough circular cells. That raises a fascinating question. If bees start with circles, where do the hexagons come from? The answer isn't advanced geometry, it's physics. Inside the hive, thousands of bees generate heat by vibrating their flight muscles. As the temperature rises, the wax softens. When neighboring cells press against one another, physical forces begin to reshape the structure. The walls flatten where they meet. Surface tension helps redistribute the wax. Slowly, the circular cells transform into stable six-sided shapes. The same kinds of forces that shape soap bubbles help shape the honeycomb. In other words, bees create the framework, but physics helps perfect the design. What looks like a carefully planned architectural masterpiece is actually a collaboration between biology and the laws of nature. The bees provide the wax, the bees provide the labor, the bees provide the heat, and physics does the final fine-tuning. So the next time you see a honeycomb, remember that you're looking at more than a collection of wax cells. You're looking at one of nature's most remarkable partnerships, where insects, mathematics, and physics come together to create something truly extraordinary. If you enjoyed this story, don't forget to like, subscribe, and join us for more surprising stories hiding in the world around us. Thanks for watching, and we'll see you in the next one.